Hello, I'm JW. This is a continuation of a series on the Brown Book, or Amendment 2 of the wiring regulations. This particular episode we're going to be looking at Part 4. Now this is a relatively lengthy section and there are a number of changes in it, so this is a relatively long video, but nevertheless we'll cover the main points there. So let's get to that and see what Part 4 has in the way of changes. So Part 4, which is protection for safety, just as it always was, and like the others it's divided up into a variety of chapters. Now, as in the previous changes, there are quite a lot of these which are fairly minor, so just say a word or two has changed, or full stop deleted, or whatever else, so you're not going to be bothering with that. However, what we are going to be bothering with is 41133, additional requirements for socket outlets and for the supply of mobile equipment for use outdoors. Now, it existed previously, but it's been expanded somewhat, so we've now got, in AC systems, additional protection by means of an RCD with a related residual operating current not exceeding 30 milliamps shall be provided for. And we've now got 3 items. Socket outlets with a rated current not exceeding 32 amps in locations where they're liable to be used by persons of capability BA1, BA3 or children, which is BA2 and BA3. Socket outlets with a rated current not exceeding 32 amps in other locations. And mobile equipment with a rated current not exceeding 32 amps for use outdoors. Now, the main thing changed here is it's now specifying BA1, 2 and 3, which basically covers everybody who isn't a skilled or instructed person. So it's not a huge change, but now it does cover pretty much everywhere, except where, as it says underneath there, where you've got the risk assessment undertaken with the involvement of a skilled person, and they've determined that it is not necessary. Now, you can't use documented risk assessments in a lot of areas. You can't use them in domestic. You can use them in some commercial or industrial locations where the installation is under the control of somebody. And as it says in Note 1, an ordinary person instructed in the use of the installation does not become an instructed person electrically or cease to be an ordinary person. So basically you can't now say, oh, well, we've told Mrs. Jones, who lives in that bungalow down the road, that she can only use this socket for a TV in the front room and she can't plug it outside or anything else. Not going to happen. So essentially what we're meaning here is any socket outlet up to 32 amps is going to need an RCD in almost all scenarios. The only cases where it might not is a controlled environment, such as you might have, say, a data center with computer equipment in it. Access to that is restricted to instructed persons only, and therefore you don't need RCDs there. So specialist environments like that, and of course you do need the risk assessment and all the rest of it before we're going to go down that route. The notes here, there's actually now 5 notes. Previously there were only 3. Note 1 is obviously one of the new ones. Some of the others have been rearranged here. And Note 4 is Appendix 2, Item 11 in respect of risk assessment. So again, we'll look at the appendixes in a later video. Now moving on the page to 4114, TN system. This includes TNS and TNCS. Now a sneaky little item has been added here, which is the section here. So it is recommended that an additional connection to earth by means of an earth electrode in accordance with chapter 54 is made to the main earthing terminal. This recommendation does not apply to outbuildings of dwellings served by the installation. So what we're talking about here is adding an earth electrode to a TNCS or TNS installation. This is nothing to do with TT, and it's not using that electrode as the primary means of earthing. This is something additional. This is actually something which has been used in other countries for many decades. So it's now a recommendation that you do that, not a requirement, but certainly something which is recommended, and it's reasonably likely that this will become a requirement at some point in the future. So what we're talking about here then is you've got your, say, TNCS installation, putting in an earth electrode outside, connecting that to the main earth terminal of the TNCS installation. It's still going to be a TNCS installation, just happens to have that additional earth electrode, and the main purpose of that is if there's some network fault where the PEN conductor or the combined neutral and earth conductor is damaged, having electrodes at the individual installations will help to reduce any touch voltages or voltages that appear on items in the event of a fault. Now in the past this was kind of already there in the form of protective equipment from bonding to your gas, water supplies and all kinds of other stuff, because traditionally those are made of metal. Of course they're not made of metal anymore, they're all plastic, and that's part of the reason why this is now a recommendation. So other countries have been doing this for years, but for some reason we have not done that in the UK. Now in terms of practicalities here, this does not mean that every time you go to somebody's house to change a light switch that you're going to have to start putting in earth electrodes and all that. what it does mean, so if you're going to be putting in a new installation, say rewire or something like that, definitely put in that additional earth electrode. In the scope of, say, rewiring somebody's house, the cost of putting in an earth electrode is minimal. It's not going to make a huge difference to the overall cost. And again, you're going to be there for quite a while anyhow, so certainly put it in those situations. And in terms of things like a block of flats or something, we're not talking about putting earth electrodes out the window and cables running down the side of the building or any of that. The easiest way there is you're going to put an electrode in, but do it for the whole building. So say a block of 10 flats or something, there's going to be some kind of intake room or something on the ground floor. That is where you're going to attach your additional earth electrode to the main earthing terminal for the whole building. It is not something you're going to have to do for individual apartments or flats within that block, so it should be fairly common sense, but just to point that out there. And again, you could put it in if it's not there, but certainly if you're doing any major work, sort of rewiring or new installations or whatever, then it's definitely something to consider. And although it's recommended now, reasonably likely that in the relatively near future it's going to become a requirement, so you may as well get ahead of it before that occurs. Now another one here, this is a relatively minor change, but it's certainly a considerable improvement. This is in 41, which is protection against fire caused by electrical equipment. And as we see here, it's where arcs, sparks or particles of high temperature may be emitted by fixed equipment in normal service. The equipment shall meet one or more of the following requirements, so a list of those there. And what's changed is this piece here, which now says arc resistant material used for this protective measure shall be of low ignitability in accordance with this standard, of low thermal conductivity and of adequate thickness to provide mechanical stability. Now previously it didn't refer to this standard at all, so it's a big improvement there, and it's now referring to this particular standard that the material needs to comply with. And again, this is something which should have been there really in the first place. Previously it said non-ignitable, which doesn't really mean anything, because anything will burn eventually if you get it hot enough and in the right conditions. So good improvement there, just say referring to this particular standard if you are going to be using material for this purpose. And again, there are quite a few of these in this book. I'm not going to look at all of them, but where it's now stating refer to a particular standard for, so in the case of this one, a particular type of material, and various others. Now this is one of the other big ones, so 42117, arc fault detection devices, or AFDD, conforming to BSEN 62606. Now this is a big change because previously these were suggested, however now we have shall be provided for these things. So this means you must provide them, it's not a choice anymore. So in the case of high-risk residential buildings, houses in multiple occupation, purpose-built student accommodation and care homes, arc fault detection is now required for single-phase AC final circuits supplying socket outlets with a rated current not exceeding 32 amps. So pretty much most of the socket outlets you're likely to be putting in. Now note one there, high-risk residential buildings are assumed to be residential buildings over 18 metres in height or in excess of 6 stories, whichever is met first. Generally one story is about 3 metres, so that's where the 18 metres comes from there. It's anticipated that in many areas high-risk residential buildings will be defined in legislation which can be subject to change over time, as well as in risk management procedures adopted by fire and rescue services. Current legislation should be applied. So basically what it's saying is that at the moment it's generally considered to be things over 18 metres in height or 6 stories, but in the future that might change to some other height or other number of stories. So of course check whatever that is at the time. So socket outlets in those locations do now require arc fault detection devices. There's no choice anymore. And for all other premises, as we've got here, the use of AFDDs conforming to that standard is recommended for single-phase AC final circuits, not for socket outlets. So that's similar to what we had before, but the main difference there is that previously it suggested a whole list of types of buildings, but now we've just got those 4 things. You will put them in. Everything else, you should consider them. And if you're going to put AFDDs in, they should be placed at the origin of the circuit to be protected, basically in the consumer unit or distribution board. And the use of AFDDs does not obviate the need to apply one or more measures provided in other clauses. So essentially you can't just put in an arc fault detection device on its own. It does need to include overcurrent protection, so your typical circuit breaker, and in most cases you're going to need to put in RCD protection as well. Now in the previous video we saw that the definitions of AFDDs can include ones which include those 3 functions in the same device. However, they're not all like that, because some of them are just an AFDD module on its own. It doesn't have any other functionality, and in some cases it might just say be an AFDD with overcurrent. doesn't have RCD protection included as well. So you do need to still consider whether you need those other things, and certainly for socket outlets, most of the time, in fact almost all the time, you're going to need all three of those. So overcurrent protection, RCD coverage, and of course AFTD as well. And that can be either a single module device or a single device with all those included, or it could be, say, a combined unit where you just clip on a AFTD module on the side. Now, another fairly large change is this one here, which is 422, precautions where particular risks of fire exist, and in specifically 4221. Now, a lot of this has been sort of rearranged and reordered from the previous version. The main changes we've now got is that in the second section here. So this now refers to standards such as BS9999. So the requirements of this regulation should be applied in addition to those of section 41 for installations in locations where any of the conditions of external influence described in 4222-6 exist. For such locations, the fire safety design of the buildings should be documented. This information should be included in a fire safety manual produced by or for the person responsible for the building. That's the responsible person, as detailed in local and or national fire safety legislation or guidance, and that includes BS 9999. And it's recommended that the electrical system designer or installer provides the person responsible for the building with details of the electrical system, setting out the basis of the design with respect to fire safety, including routine maintenance requirements. Now, this is a fairly large change in that previously electrical stuff was kind of detached from fire safety, but now it definitely isn't, and really it shouldn't have been in the first place, because if you're going to go into a building and start putting holes in the walls and ceilings and putting in cables and all the rest of it, all of these things can have an effect on the fire performance of the building. And one specific thing we've got here is where it's determined that cables should have an improved fire performance but are not covered by 422 to 426. This may be achieved by using cables with a minimum light transmittance of 60% when tested in accordance with this standard, and limited flame propagation according to the minimum requirements of the relevant part of that standard. And where cable management systems are used, cables shall conform to minimum requirements of that standard as well. Now, the minimum light transmittance thing, there is a certain test in that standard, which basically means when a cable is burned or set on fire, it will give off certain amounts of smoke or other toxic gases or whatever else, and it's just referring to the amount of light which can pass through those smoke and fumes. And the other ones also refer to flame retardant and flame proof type things and what happens when things are on fire. It's all documented in those other standards, which we're not covering here. They're fairly expensive to purchase. But the real takeaway from this is that if you're going to be installing stuff in a building, you do need to consider how that's going to affect the fire performance of the building, and therefore you need to consult with the responsible person for that building and make sure what you're doing and putting in is actually suitable and is not going to impair the performance of it. And there's an example here. You don't want to go into, say, a block of flats with a big long corridor, start sticking up plastic trunking and standard PVC cabling in there, because if there was a fire, that kind of cable gives off huge amounts of toxic black smoke and all kinds of other toxic gases as well. That is going to severely impair people escaping from the building, could result in severe injury and actually killing people. So just be aware of fire performance and how things you're going to put in will affect that. Same as putting big holes through the walls. If you've got, say, a wall or something that's, say, a fire-resisting construction, if you're going to drill massive holes through it, that's going to damage and impair the fire performance. So again, that's not something you really want to be doing. Now, another new one here is 4222, which covers protected escape routes. Now, in the previous video, we saw that that is a new definition. So that covers situations where, say, you have a apartment block or a block of offices or something. The protected escape routes are those which people are going to use to evacuate the building in the event of an emergency, such as a fire. And that's typically going to be stairways, corridors, that kind of thing. So cables or other electrical equipment shall not be installed in a protective escape route unless it's part of an essential fire safety or related safety system, general needs lighting, or socket outlets provided for cleaning or maintenance. And there's guidance in Appendix 13, we'll look at that in another video. So what this means is that if you're going to go into, say, a block of flats, you do not want to be installing just general random cables in the corridors or the stairway unless it is one of those things. So if it's for lighting in that particular stairway, well, that's absolutely fine. If it just means just shoving a cable through there because someone on the ground floor wanted to socket outside and it just happens to go through all the corridors up to their flat, not something you should be doing, because that's not related to any of those 3 items. So all you want in, say, apartment block or something like that is lighting for that particular area, some socket outlets provided for cleaning and maintenance, so vacuum cleaner, that sort of thing, or where it's part of a fire safety or related safety system, the fire alarm system would be an obvious example of that, and things like emergency lighting as well. So general purpose cabling should not be installed in escape routes. You want to put that somewhere else. Most apartment blocks, that's how we have risers and things like that, where that type of cabling should be put. And those generally are fire resistant construction, so if a fire does occur, those cables aren't going to impair people escaping from the building. And you see the note at the top of this page. Generally, this means cables in a protected escape route should be limited to lighting associated accessories, emergency lighting and fire detection alarm systems. Although cables for other safety systems may be necessary, hospitals may have special requirements as detailed in section 710. And then following on from this, if you are going to put cables in there for one of those specific purposes, only cables that meet the following requirements shall be installed in protected escape routes. Cables meeting the requirements of 560.8.1, or cables with resistance to flame propagation according to the relevant standards that are listed there. And again, that's 60% light transmittance, which we saw previously. Cables in protected escape routes shall be as short as practicable. Cables encroaching on escape routes shall not be installed within arm's reach unless they are provided with protection against mechanical damage. And when used in protected escape routes, cable management systems shall be one or more of the following types and shall be of limited smoke production so as not to inhibit escape. And there's a list of a variety of standards there which they should comply with. Now the upshot of this is that installing plastic or PVC mini trunking in the stairways of some apartment block or office block or something is no longer permitted, because PVC trunking is not flame retardant particularly, and most importantly, when it does go on fire, it gives off huge amounts of black toxic gases and smoke and everything else. So you do not want to be putting that in there. And likewise, standard PVC cabling not permitted anymore. It's got to be a specific type of cable that complies with one of those standards. So mini trunking in the corridors, yep, it's gone away. Plastic cabling there, nope, not allowed. And even other things such as you've got there, it needs to be all flame or non-flame propagating and not give off fumes, toxic gases and smoke and all of that. Now this may seem like common sense, and it probably is, but unfortunately there's lots of buildings out there where, say, blocks of flats particularly, you go in there and you can see it's just a mini trunking stuck around the corridors and up and down the stairways. No longer applies. In terms of went on the EICR and saw that, really that's got to be a C2 now, because specifically prohibited here, and if there was a fire or something, that could severely impair people's ability to evacuate the building in a safe and timely fashion. Now let's move on to 443.4, overvoltage control. Now what this basically means is surge protection. This was in the previous blue book, but this has been extensively revised and whole chunks have been deleted, as you see at the bottom of the picture there. So this is where you need to install surge protection. Now previously there was a list of various things here, and there was a stupid risk assessment thing and a map of the country with how much lightning might occur there and all that bother. Fortunately, all of that has been swept away and thrown in the bin, because it shouldn't have been in here in the first place. So now what we've got is protection against transient overvoltages or surges shall be provided where the consequence caused by the overvoltage could result in one of these things. So serious injury to or loss of human life, failure of a safety service, as defined in Part 2, significant financial or data loss. So those three things pretty much cover the vast majority of electrical installations. Now, serious injury to or loss of human life isn't going to be in many of them. Certainly things like hospitals or where there's medical equipment could be a category there. Failure of a safety service actually covers a huge range of things, because safety services are things like emergency lighting, fire alarms, smoke alarms, and all kinds of other stuff. So yes, if you've got, say, smoke alarms installed in your domestic house, that is a safety service. Surge protection is required there, because if you have an overvoltage event or a surge, you don't have surge protection installed, those smoke detectors could be destroyed, or smoke alarms could be destroyed, and they don't work anymore. Then there's a fire, people don't get told about it because they're not working, and people die. So that's not a good situation. So yes, surge protection is now pretty much required in every building. And of course the third one there is significant financial or data loss. Now, what is significant? Well, essentially it's anything which you wouldn't want to have to pay to replace compared to the cost of the surge protection device. So if you're, say, looking at domestic property, a television, hundreds of pounds, surge protection device, less than £100. So again, pretty much any domestic property is going to now need surge protection, whether you like it or not, because all that stuff in there could easily be damaged. Say one television, one computer, one iPad, laptop or whatever else. If one of those is damaged, that's obviously a significant financial loss. And of course, in the terms of things like laptops, computers and whatever else, a significant data loss as well, because if it's blown up and destroyed, anything out in it, of course, is lost as well. Now, for all other cases, protection against transient overvoltage shall be provided. So in other words, even if it's not any of those things, you still need to put it in, unless the owner of the installation declares it's not required due to any loss or damage being tolerable, and they accept the risk of damage to equipment and any consequential loss. Now, this is the old thing where people can sign some disclaimer saying, oh yes, we don't want surge protection because we want to save £50 on our consumer unit, and we can't be bothered to pay that because we don't consider that the thousands of pounds worth of IT equipment in our room isn't valuable. Now, this is really a load of nonsense because, as we can see there, 99% of installations are going to have things in it vastly in excess of the cost of a surge protective device, so there's really no excuse not to put it in. And the problem here is that even if you get someone to sign a bit of paper saying, oh yes, we don't want it because of excuses, and they want to save, say, £100 on the cost of putting in the surge protective device in their new consumer unit or their new installation, the problem is, does the person that's signing it actually understand what it is they're signing and what the risk is? And the reality in most cases is going to be no. Certainly in a domestic environment, Mrs. Jones living in that bungalow down the road is not going to understand what surge protection really is or the consequences of it or anything else until, of course, her TV blows up and doesn't work anymore, and then she goes, oh well, I didn't understand it and you told me this and someone said that. So do not go down the route of getting people to sign bits of paper. It's absolute nonsense. The takeaway from this is that surge protection is required. Fit it, don't give people a choice. It's not a huge cost, certainly for domestic items, and even for larger industrial commercial ones, relative to the scope of the works, it's again not a huge percentage. Of course they cost more than the domestic one, but if you're installing something £1,000 or tens of thousands of pounds or even more, spending £500 or £1,000 on the surge protection device, it's really not a big deal. The bits that have been deleted here are the risk assessment and the map and all that other nonsense. All that has been swept away, so you don't have to bother about it anymore. And good job as well, because it was mostly irrelevant. The reason it's gone primarily is that A, it shouldn't have been in there, because it's basically taken out of other standards, so it still exists elsewhere if you're that bothered. But the real takeaway there is the fact that most surges in installations are not caused by lightning. Lightning can certainly be a cause, but the vast majority are actually caused by switching and other loads on this system inside and external to your installation. So the whole risk assessment thing was a bit of nonsense. Now that is pretty much it for part 4 there, and that was, say, fairly lengthy, but nevertheless that's pretty much it. There are again a few minor items there, sort of just changes one word or three or something, but I'm not going to go over those. So the main takeaways from this is that arc fault detection is now required in a certain number of installations, strongly recommended for all others, and surge protection is required in pretty much all installations, unless it's one of those ridiculously rare ones where it's some wooden garden shed with a single incandescent lamp hanging in it, and that's pretty much it. But you'd really have to search very hard to find things where surge protection was not a requirement. So I'm going to quote for any kind of installation, include surge protection as standard. It's not something people can pick and choose. It's something that's required, just like RCDs and overcurrent protection and all the rest. Stick it in. Don't give people the choice, because they won't actually understand what they're choosing, even if you gave them the option. So that is it for this one. We'll have a look at part 5 next time. But until then, thanks for watching.